All right, so in the next one, and also the one after, we will have what is the longest single formula in the entire course. And what happens is we take one of the MC delta T formulas that we used in question 2, and we set it equal to another one. So the mass of the metal multiplied by the specific heat of the metal multiplied by the change in temperature of the metal gives the certain amount of heat lost for the metal. So I'm going to write that a little bit more consistently though. And because that heat gets lost from the metal and goes to the water, then it's equal to another one of those MC delta T formulas. So the mass of the water, specific heat constant for water, and the change in temperature for water. Now we do have to be careful on these changes in temperatures. We want to make sure that the way this works out, that every part of this stays positive. And so we do have to very specifically subtract in a particular order to make that line up. So let's look at this. Let's see what we've got, what we can plug in. So the mass of the metal, it's an unknown metal. So we just have 117 grams. Because it's an unknown metal, we just have Cm. So just the specific heat of the metal. We don't know what it is if we don't know the type of metal. The change in temperature of the metal is 85 down to 16. Okay, then the mass of the water, 247 grams. Because it's water, 1.00 calories per gram degrees Celsius. So as it turns out, water is part of the definition for how calories are set up. Then the change in temperature, we want to make sure to subtract so that it stays positive, so we'll have 16 minus 10. If we check the units, we can see most of this is going to go away because grams here can cancel grams for there. Then these Celsius will combine and cancel with those Celsius over here, and so the only units left over are this ugly bunch, which just happens to be what we're looking for. So it's an ugly set of units, but it is the thing that we need here. What that means is we can just work this down, simplify the numbers, and get some kind of an answer. So on the left-hand side, 117 times C is just that. We don't really know what to do with it. Then 85 minus 16 is 69. Then over here, 247 times 1 is just 247, and 16 minus 10 is just 6. So we went from a very long formula to something that's relatively short. We can combine a bit further. So on the left-hand side, 117 times 69 is apparently 8073, and that's times the specific heat that we're still looking for. And on the other side, 247 times 6 will give us 1482. And finally, to solve for C, we want to divide by 8073. Now, a lot of times students will see this and panic and then try to divide in the other way, but specific heats, especially for metals, are typically very small numbers. So, in fact, here we get 0.1836. That's actually relatively high for a metal. It's roughly double what we had for copper earlier.